Hello everyone, so this is my attempt on solving AtCoder round 392. So without further ado, I'll just start solving problem A.
One eternity later.
Let's go! So I started my contest about 1 minute late. The problem A is not very hard, just asking whether A times B can be equal to C. The solution is very simple too, just sort the number and do a simple if check. And I got AC really quick for this problem. I almost entered the wrong capitalization for this problem. Beep! Okay, we got accepted on the first problem. Question B is really easy too. It's just asking whether any elements are missing in the sequence. I get troubled a bit because it's been a while for me to code competitive programming problems, so I keep changing between using vector and set. Okay, we got another accepted. Nice. Then I get started to read problem C. It's not really hard, the problem is, but it's more of like a comprehension question. It took me a while to understand the question. I got it a simple solution as per my understanding, but it turns out the solution has a bit of an issue. I keep reading more and more of the question because I don't seem to get what the question is asking. Oops. What? Person 3 is wearing... staring at person number what? Person number 2. Person number 2 is what? Wearing number 3, right? Find the number written on the bib of the person. That the person wearing the bib with... What is this? This is a language problem, not a competitive programming problem. Person 3 is wearing the bib with the number 1 and the person number... Huh? What? Wait, what is bib? Oh, so cute. I thought it's the Arabic one. After a while, I ended up getting the solution for this problem. I just had one issue. I had to remove the zero padding at the beginning of the vector. 3412. Okay, this sounds right. How do we not print the first element? Should we do this? No, this is too easy. No. How about this?
Oh, hell no! No. What the Sigma?
Yeah. After having fun for a bit, I continued and I got AC on this third problem. Okay, nice. The fourth problem is really simple. You will just have to check for each pair of dice which two pair of dice has the highest probability to show the same number when rolled. This one is actually wasting me a lot of time because I actually misunderstood the question. Instead of getting what the problem asked, I was looking for the face that has the highest probability to show from each pair of dice, which is obviously wrong. Oh shit! Oh no, I read the problem wrong. PS, it was not me that is reading the problem wrong. I simply read too fast and I didn't even understand the question on the first hand. I read the problem once again and realized that the n is actually less than 100. it means I can simply like, iterate each pair of dice and do a computation on it. At some point, I'm confused on whether the computation will fit within the time limit because the s, the total number of faces for all dices, are 10 to the power of 5, which will not fit if I were to do a on squared times s. After trying some ideas on my notebook, I found an observation that if we were to sort the array and iterate using map, finding the small elements instead the bigger ones, it would lead to a better squared s times n squared times log s solution, which is feasible and fit within the time limit. So I implemented the solution and got accepted soon after. So for implementation detail, instead of using double floating point, I'm using fraction classes instead. I think we should spend some time actually doing the analysis of the time complexity. This would be an accepted, but I don't know why it's okay actually to do this. Okay, let me think about it. If I do this iteration, would it actually be okay? Oh yeah, by the way, the stretches on my notebook before was actually happening right after I submitted my solution. So at this point, I didn't prove my solution yet, but my intuition says it's correct. So the complexity would be K1 times and plus K2 times n minus 1, something like this. Wait, how many minutes do we have left in the contest? Let me see the standing. We're doing pretty bad, I think. Yeah, we're doing really bad. Someone already solved all of the problems. So for problem E, it is very easy, I believe. It's just a simple minimum spanning tree problem with extra greedy. I've seen some of my friends actually trying to solve this problem and got some wrong answers. But I think that can be avoided if we code it carefully. Let me check this one. Oh yeah, because all of them are connected to trees, something like this. And then this here. One. The edge one is changing from... What? What? Should be like this. Whoop. 3 will change to 1. 3 will change to 2. Is it? 3 will change to 4. 3 will change... Okay, this looks good. Boop. Okay, we got correct! Let's go. Maybe because I'm very familiar with graph and minimum spanning tree, I actually spent less time solving problem E than solving problem D before. I read the problem F and realized this one is a very classical problem, which is a balanced binary search tree problem. At first, I thought there's like a simpler solution, which lets you do the problem from the back, or like backwards, but I think that would be overkill and I feel like it's not worth time spending because there's already a very known solution for this. So I just decided to code the easy solution using the templates. Node star. Root is new node. New node. Actually, this is my first time using this tree thing from the template, so I'm not really familiar with how to declare everything and initialize everything. Four, two, three, one. Oh, it works just like that. Insane. So I didn't have to do anything, right? This is suspicious. Because I think it was too easy because the problem is just like this, so I decided to do more test cases. So we inserted at position 1, we inserted 2 at position 2, and then we inserted 3 at position 1. We inserted 4 at position 3, and then we inserted position 4. Would it be time limit exceeded? Never mind. Oh, I'm ranked 600. Let's go. One more problem. For integers A, B, C, if they satisfy One thing I like about AtCoder is actually the problems descriptions are very short. You can skim them and you will immediately understand the question. What? Let me think. We need to find. I have a gut that this problem is actually very similar, or I've encountered this problem before. The solution was fast Fourier transform, but I didn't remember whether it was like the easiest version or like the hardest version of this problem. At one point, I was actually so confused on how to solve this problem. This problem seems really hard. And also at one point, I think the solution was not as simple as FFT, as my gut or my intuition says. So I approached so many solutions like square decomposition and some more other jumping greedy optimizations. Let's check apa ada apa ya. Wait, this is the exact same problem that I made. Until at one point I realized that I actually problem set this problem before, like 5 months ago. The solution is actually exactly the same. And that's it. I ended up getting all problems accepted in this contest with only seconds left in the time. I feel like this is a very bad performance because some of the problems are very classical and are known problem. And I feel like if the problems are more original, I can probably solve only like 5 or 4 problems. And that's it. This is my first competitive programming screencast videos. I wish I could make some more videos in the future. Probably I'll solve some more harder problems because I just got back to CP after not contesting for a while.